6.4 Scientific Notation. Scientific notation, vocabulary to remember. Scientific notation, a number written in the form a times 10 to the x, where a is larger than 1, yet smaller than 10. Scientific notation, key concept number 1. Standard forms of scientific notation. Step 1. Move the decimal point until it is to the right of the first non-zero digit. The result is the real number a. Note the number of places that you move the decimal point is n. Step 3. If the decimal point is moved to the left, write the number as a times 10 to the n. And if the decimal point is moved to the right, write the number as a times 10 to the negative n. Step 4. Remove any unnecessary zeros. Key concept number 2. Scientific notation, the standard form. Step 1. In a times 10 to the n, note whether n is larger than or smaller than 0. If n is larger than 0, move the decimal point n places right, and if n is smaller than 0, move the decimal point n places left. Step 3. Insert zeros as needed. Now on to 6.5. 6.5. Exponential functions. Vocabulary to remember. Exponential function. Y equals ab to the x, where a doesn't equal 0, b is larger than 1, and b does not equal 1. Note that they are nonlinear. Exponential growth function. Y equals ab to the x, where a is larger than 0, and b is larger than 1. Exponential decay function. Y equals ab to the x, where a is larger than 0, and b is in between 0 and 1. 6.5 Exponential functions. Key concepts. Graphing exponential functions. To review, x is domain and y is range. In exponential growth, the graph goes up, and at decay, it goes down. The range y that approaches but never reaches 0. Graphing exponential growth. No x-intercept. As the domain x increases, the range y also increases. As the domain decreases, the range approaches but never reaches 0. Note that the graph is going up. Graphing exponential decay. No x-intercept. As the domain x increases, the range y approaches but never reaches 0. As the domain decreases, the range increases. Note that the graph is going down. We're almost there, just hang in there. 6.6 Growth and decay. Vocabulary to remember. Compound interest. Interest earned or paid on both the initial investment and previously earned interest. 6.6 Growth and decay. Key concept number 1. Equation for exponential growth. Base equation. Y equals a times the sum of 1 and r to the t, where y is the final amount, a is the initial amount, r is the rate of change expressed as a decimal, and t is time. Key concept number 2. Equation for exponential decay. Base equation. Y equals a times the difference of 1 and r to the t, where y is the final amount, a is the initial amount, r is the rate of change expressed as a decimal, and t is time. Key concept number 3. Equation for compound interest. Base equation. A equals p times the sum of 1 and r divided by n to the nt power, where a equals the current amount, p is the principal or initial amount, r is the rate of interest expressed as a decimal, n is the number of times compounded each year, and t is time. And that's it. You made it. We hope you enjoyed, and thank you for watching. Sponsored by AMS Mass Productions, making high-quality video productions since, well, like 10 minutes ago.
Created using Powtoon.